many known names on this the guest list here. That's very cool. Like you would have to wait 2 years in between conferences in real life to get that. So thank you to everyone who attending.
Sorry, one short interruption. What I forgot to say is we would ask everyone to keep the questions for afterwards. You can type in your questions into the chat. We will record the session, and sorry for the interruption, Daniel. Please go.
You have one more to read. Oh, working with Paul Romer. This is just an aside before the presentation, but that was that's actually kind of what got me started on this whole environment, because the kind of neoclassical perspective was that every single atom on planet Earth could be rearranged to better serve human demands. And the whole point of GDP is that it measures how much we rearrange atoms to serve people, and then we constantly come up with more and more clever ways to rearrange things. And then in opposition to that is the kind of the natural capital idea that there are some configurations of atoms, like the Amazon rainforest or the thermohaline circulation, that are actually pretty darn good the way they are, and that we probably maybe could improve on them, but most likely cannot, and therefore that we should be more respectful and kind of economically value natural capital. So that's was totally influential on me being here today, I would say. Let's just hit share screen and push play. Hauke, can you give me a thumbs up that you see the screen okay?
Yes.
Yeah, great. This is the paper that I'm talking about if anyone at home wants to just follow along. It's kind of, we wrote this with a few colleagues as an easy to read, general audience kind of overview of the topic of spatial footprinting and how spatial data can be linked to footprint accounts. This is not the only paper. There's also one with Arnold and a few colleagues from CML. So, and I've put links at the end of the presentation to a few overview papers, but it's kind of a good way to get in and browse along if you want to follow along in the literature with the talk. Stefan Gilliam was another co-author. He's doing the ERC project on fine print, which is a spatially explicit material footprinting to link it to specific mines and production facilities. Kaichiro and I collaborate quite a lot on a variety of topics, and Javier Godard, of course, is the mastermind of the Trace.Earth project, which follows a lot of the same ideas, but uses bills of lading, which are these documents filed by truck drivers and ships at the border to tell you exactly what's on the truck and what's on the ship, and trying to put those together into a global MRAO. I feel like that's a very interesting idea. It also has a lot of challenges in the data and how accurately or legibly truck drivers write down the contents of their truck, but and also the kind of availability of that data at scale has been a challenge. But it's a really interesting idea and has let them progress very nicely on that Trace.Earth project. So the kind of big picture perspective on spatial footprinting, there's so much has been invested on Earth observation over the past 20 or 30 years. We have billions of euros and so many satellites. The ESA, NASA, Japanese, agencies have so much airborne kind of ability to observe in almost real time the surface of our planet. With hyperspectral imaging, with machine learning, you can classify those the different data layers coming from satellites and have a really powerful understanding of what exactly is environmentally what the surface of the planet looks like. There was a Nature paper just 2 days ago that came out that they tuned the satellite so well it could find individual trees in the Sahel. So that's the kind of level of detail that you can get, and commercial providers are providing this in almost real time, where you can just schedule when you want the satellite data, and it will pass over for you. So we have these big environmental problems, and we have so much ability to observe how they're unfolding. But the kind of rationale that, as I see it, it very rarely does that information come from it almost always stays in the science sphere. It stays with natural scientists and with kind of academic research community. And it very rarely ever makes it to business decision desks, to corporations, to politicians, to local governments. That's Of course, there are the theoretical difficulties of matching physical activity to monetary transactions. And it's also just a matter of different language and different classification systems. So even in a very practical sense, it's really hard to map rice that you can identify from a satellite and the kind of a rice paddy to the particular economic classifications where it will inform a specific corporate decision. So I think in a variety of ways, there's just a big chasm between the set of Earth observation data and the actual day-to-day economic decisions in companies, which are made using Excel, using monetary figures, using Oracle, SAP. And that's just a big gap that we, as industrial ecologists, should be working to fill. The best definition I heard of industrial ecology is indeed that it is the study of the physical flows which underpin the monetary economy. We should have insights into the physical flows which drive and permit our monetary economy. Just thinking about the main tools, LCA, IO, and MFA of industrial ecology. The LCA tools are very precise, very good on product level detail, not comprehensive, don't cover the service sector of the economy. There's huge sections of the economy, entertainment industry, banking, finance, that LCA has no insight into. And it's also very difficult to get, it's very labor intensive to do an LCA study. So that's kind of drawback on the LCA kind of perspective. MFA similarly is usually very precise. And IO is comprehensive and covers large sections of the economy, and it's very cheap to get data out of the database once it's built, but it always lacks precision and granularity. So this is, I kind of have been coming into this from the IO field to find more and more precision in the IO methods and look at kind of essentially what is hybrid LCA IO methods, where you map an LCA study in and you slice it into an IO table. So that's the challenge. And the kind of core idea of spatial footprinting is that instead of, so normally in an IO account or in the matrix setup of an LCA study, you have total, let's say, liters of paint spilled with some process. You have a total physical unit, liters of paint spilled, and that's part of the production recipe in a priority year in sort of a satellite account in the IO framework. Imagine just breaking that into multiple pixels. So you have paint spilled in pixel 1, paint spilled in pixel 2, paint spilled in pixel 3. So instead of having the line items be just a total, you actually take a grid, a raster map, vectorize it into a long column worth of numbers where every pixel corresponds, where every row, sorry, corresponds to one pixel on the map. And that's the heart of how you then run the Leontief inverse and kind of do the application. And really, the more I kind of have experience showing industrial ecology results outside the real world, I just always realize in kind of this TRL language, this technology readiness level, industrial ecology is often we're insufficient and we're not moving fast enough toward actually practical results. And I think where we should be in 15, 20 years is providing data directly into Oracle, SAP, wired into cloud providers. It should be kind of this environmental data and including live remote sensing data should be wired directly into the same software and the same application. So you have it side by side in Excel. The economic impact and the environmental impact should be in the same set of software. So that's the kind of gap that I think we can work to bridge, and that and using spatial footprinting is a super nice solution because you have the environmental data and you essentially use latitude, longitude as the coordinate system to combine the two. So you say, if there's an environmental stress in this place, and if there's an environmental activity in this place, the two are then bound together, associated with each other. And you can then link the environmental attribute, which occurs at the same place, to the economic activity, and then trace that economic activity through an LCA, through an IO table, and then through all your economic shock and forecasting models, looking forward in time as well. So the challenge, of course, is we have all of this data at the national level in the IO framework, but we want it at the pixel level. That's the core challenge. You want to see not just total coffee exports from Ecuador, but where in Ecuador does the coffee come from? So the idea here is a spatial production inventory, so we can spatialize more accurately where within a country the production is coming from. We can use a lot of different data sets that help do that. In the US, there's this cropland data layer, a CDL, produced by the, sorry, not CDC, but I'm blanking on the name, the Department of Agriculture. So the cropland data layer and MapSpan models will tell you quite precisely where and croplands.org. There are a number of data sets that show you where different cropping activity is. We can observe in almost real time where forest loss is, where fishing activity is occurring. And then furthermore, there's you can attribute observed environmental impact to various economic activities which are co-located. So we can, if we know where the cropping is occurring and we can observe where the deforestation is occurring, you just spatially overlay the two of them, and then you can follow the deforestation to the implicated crop, and then that through the IO and the supply chain data sets. I'll skip this graphic, but this is just an easy graphic that illustrates. And I think everyone on the call is used to working with supply chain data. That's kind of a core data set for all of the industrial ecology methods. Yeah, I just added a bit of a blurb slide on the EUR-MRO, which I'm quite involved in. It's quite comprehensive, so it covers a lot of sectors, and it's also, we've had nice interest in that MRO from also the business sector, and kind of more finance applications and commercial interest. So I think that's super exciting to see that there is increasing awareness of IO methods, and what IO kind of global supply chain data sets can bring to the table. So we see a lot of increased interest in that field. And I think that linking in more live satellite data and more spatial data is going to make that even more compelling. Everyone wants to see maps, and especially business people, they especially want to see maps, and they want to see how their company has a footprint or how they're exposed to a certain spatial stress. It's going to sell like hotcakes if you set up that kind of analysis. So I feel there's a really big research opportunity to flesh out those ideas and make use of the available data sets. This was kind of the infographic we had in the commentary paper, but the idea was just that we go from country level statistics, which all data has been so far, to the pixel level. So we can observe impacts at a detailed level. So that's from satellites, let's say on deforestation, Global Forest Watch. We can overlay that, like just a latitude, longitude grid overlay using tools like GDAL. I use a lot this set of geospatial data analysis tools to manipulate the actual data. And then you overlay the observed environmental stress with some inventory of production activity, let's say a MapSpan map of where soy is grown, or a gridded livestock of the world map of where cows are grazing, and then you can find how that crop or that cow, that commodity is associated with the implicated environmental pressure. We can also imagine, so localizing economic activity is not a new thing. This map is from the CIA from the 50s when they were trying to localize in Thailand where different economic activities happen. So there is already a lot of data, and there's a lot of methods for how to localize economic activity below the country level. We're also seeing a lot of that, I would say, with a number of really good subnational MROs coming up. So that's also very, very heartening. How are we on time here? Let's just take a look. I didn't set that up. So on the right here, we can see how the biodiversity footprint. So one study, one of the first studies that Kaichiro and I did with the spatial footprinting was connecting the IUCN red list of threatened species and the extent of occurrence maps from each species. So we know where each species lives from the IUCN, and we know and we also know from the red list which activities and which crops are threatening that species. So this monkey is threatened due to deforestation, or that turtle is threatened due to agricultural pollution. So you have a map of where the species lives, which economic activities are implicated in causing its threat. So we just simply overlaid. We said that that this turtle was threatened by let's say two activities. So rice farming and deforestation, both equal threats. So 50% of the turtles' threat is due to rice farming. And then of that rice farming, 2% is through the MRO is finally demanded by Germany, let's say. And then the frog is 100% threatened by rice farming, and 7% of of that rice is produced in service of final demand of Germany. So then you take the 2% of the turtle polygon, 7% of the frog polygon, stack them up on top of each other, and then you'll end up with a map showing in each kind of pixel how many species fractions are attributed or kind of put at risk by the economic activity in a given destination country. So we prepared a series of these maps. So for a given consumer, you look globally, spatially, where is its biodiversity footprint falling? And we got some really interesting results from it, like Kazakhstan, a very minor supplier of goods into the US, but a key supplier of cotton, which goes into Bangladesh and Italy to be spun to suits and sold via H&M and US retail shops. And actually a number of threatened species which are threatened directly because of water abstraction and cotton production in Kazakhstan. So the US has a very small economic footprint, but actually quite large biodiversity footprint in Central Asia. So that was some quite nice findings that also came out of that kind of approach. We had a few zoom-ins here as well, just where you can see the kind of level of detail that we could get at. So this was only using the production at the national level. We did not, in this paper, go and find where within the country those different economic activities took place. This was a few years old paper, and we just hadn't done that at that point. So that's but even with that limitation, we still had quite compelling results. This kind of this figure presents the exact same thing in another way. So if there's if we have a map of where the CO2 emissions associated with economic activity 1 are, map of CO2 emissions associated with economic activity 2. So on the left here, so on sector 1 emits in central China, sector 2 emits mostly on coastal China. And then we run it through the trade model, and you see that country B on the top to upper right consumes a lot of good 1 and very little of good 2. And as a result, country B's footprint in China is heavily dominated in sector 1 spatial location. That gives you the idea of kind of what's going on with the model. And then we generated results globally. This was for the PM 2.5 footprint because we linked PM 2.5 emissions with US final demand and how those emissions are produced mostly from power plants and attributed that to US final demand. So here, always with footprint and supply chain kind of discussions, it comes down to two perspectives or two narratives. It's a responsibility narrative, like because of your activity or your purchasing, you are responsible for driving these impacts somewhere else. Or it comes to a risk narrative where you want to be consuming this thing, but you're at risk because if there's some disruption or shock upstream in your supply chain, your continued consumption is at risk. I think in the kind of finance and business perspective, the risk is definitely the more prevalent and often in more environmental and kind of social change, consumption reduction, we talk more about the responsibility. So your footprint is kind of viewed as a negative. You're causing that problem, but you can also understand that you are at risk or your continued supply of that good is jeopardized by a potential shock. So under responsibility, we're always measuring kind of environmental and human health and well-being indicators. So how your purchases or the goods, the basket of goods you're demanding is driving health and well-being impacts like labor or human health or biodiversity health. And I would say in general, all of the SDG targets are mostly about responsibility, that you don't want to be worsening those SDG targets. You don't want to be contributing to poverty. You don't want to be contributing to water scarcity. So we can view it in that sense. And I would say the big picture goal is, especially in Northern Europe, where I guess our kind of virtual conference is, we want to avoid that we clean up at home and actually just offshore or outsource all of our impacts. So that's the key possibility opened by Scope 3 kind of footprint accounting. So you just avoid doing that. And then on the risk perspective, it's also quite interesting. You can you can also imagine now applying spatially explicit stressors, like a spatial map of predicted heat stress globally, or a spatial map of how crop patterns might change and how this might affect overlay that with current cropping and see how climatic shifts will change the composition of crops that are available to you. You can also imagine this aquifer depletion, that those are spatially explicit. We know where the world's aquifers are. So doing some kind of like a raster and geospatially defined stress that you apply, instead of applying a stress in a single economic sector or across a whole country, you apply it using a latitude, longitude, like a set of polygons or a raster map. So that's this 427 business. Is a really interesting business. They've been getting nothing but success and a lot of good press coverage and really interesting product offering, where they look at the physical climate risk to supply chains. They say physically, where do your suppliers locate? Are they on coastal Thailand? Are you actually buying things from Dhaka, Bangladesh, where we know in 20 years there'll be an increased prevalence of flooding? So they look at the physical climate change risk. I think mostly flooding, and then also heat stress would be another one. And maybe the data are always very weak, but how weather shifts would also affect that. And there's also a spatial finance initiative. So I'm giving this talk both today and then also tomorrow at the Turing Institute, which is a kind of Oxford-affiliated research institute working mostly with big data and AI, kind of a computer-oriented work. But because they're connected to the finance market and kind of financiers, they're very interested in seeing how the supply chain and spatial information can also be used to understand portfolio risk and ESG stressors. So if my portfolio is geospatially all concentrated, or my tier 1 or tier 2 suppliers are geospatially concentrated in the risk zone, then that's a terrible portfolio to be holding. So that's quite a powerful, I would say, an interesting narrative to explore as well. The big limitations of the method, I would say two broad limitations. One is that this coupling of economic activity and environmental impact is not necessarily one-to-one. So you don't always know that this economic activity caused that impact, or that risk will endanger that economic activity. Also, they can be offset in space. So it could be that the farm here causes water abstraction and water scarcity upstream, or actually emits pollution, which only causes eutrophication downstream. So it could be that the economic activity is spatially offset from its impact. So you observe eutrophication, and you should be pointing your finger at the farm upstream, but you actually point your finger incorrectly at the farm at the river mouth. So this kind of spatial offsetting is a potential risk. And then also offset in time. So it could be that an economic activity occurs in year 1, and then that factory shuts down or the industry moves, and the impact only shows up a few years later. They pollute the soil, and you only see the observation much later on. And there's also issues with the vintaging and like this kind of classic thing of deforestation, and then first they graze cows and then soy fields move in. So which of those crops, or how do you handle the vintaging of assigning the responsibility for that deforestation among that kind of multi-year basket of product outputs? So these issues are real. And the other thing that I've kind of gone around a little bit in this presentation is I've been presenting work that's all using the national level trade data. So we still don't know that this pixel from this country ended up in that pixel of consumption in that country. We still know that the pixel is produced in this kind of area of the country, but then it gets mixed into a general basket or general ship full of all mixed goods leaving the country when it enters the country-to-country MRO model. So a global subnational MRO model would be the logical solution. That's kind of, and I think the trace.earth approach is going that way. It's very data intensive and very hard to collect that sort of data. And I think to a large extent, we just don't even know where, if different products produced in different places are bound for domestic versus if they're bound for domestic consumers or export consumers. And often the domestic bound goods have can have a sharply different environmental profile than foreign-bound goods. So shade-grown coffee or organic tomatoes might be either consumed all, the country keeps the good stuff and sends the bad abroad, like Foster's beer, or the country could send the good stuff, sell the good stuff, and keep the lower quality stuff for domestic consumption. That's something we can't tell using national MRIOs, and getting that subnational trade data is very tricky. So that's I would say, now and probably will continue to be a limitation in the future. So also in the commentary, we were reflecting that it's not just us on the more economics industrial ecology side who can do more to advance this, but we can also be more specific about what we're asking from the Earth observation community. Basically, the more that the Earth observation researchers can do to tag their observed environmental stresses to economic activities, then the easier it is to link those stresses to products, implicated products. So we can use spatial overlap, but maybe the people working with a particular satellite sensor may actually have a better sense from also ground truthing or their kind of anecdotal knowledge of the process, which industries are really implicated. And that's something that we can ask producers of geospatial data, of Earth observation data, to do as much as they can to tag it with economic data, and preferably even tagging it with economic classification. So not just tagging with more Earth observation classification schemes, but tagging it with HS codes or kind of known product codes, if possible. To some extent, there is also political limitations to that. Like when we worked with the IUCN data, the IUCN are decided early on in the process when they designed the classification system for the red list. They decided not to name individual products as implicated in causing a species threat, because they felt that they would run into local challenges with data collection or political challenges in providing that data set if they implicated a particular commodity, even if they clearly knew it was, I don't know, rice or sugarcane, which was causing it. They preferred to say agricultural pollution or a forest loss, instead of saying we actually know it's for making bamboo lawn furniture. So there were political sensitivities around how much different agencies were willing to point the finger, even if they did know, because WWF has extensive global network of field stations who really, I would say, have a quite good knowledge of the economic and environmental activities kind of situation in all of the field sites where they work. So just to kind of come to zoom out and close, that's what I feel that the broad promise of spatial footprinting is. It will connect, like on the one side, businesses, consumers, and politicians. They want precise information tagged to very particular products. They want actionable information that lines up with their Excel spreadsheets and known economic decision-making models. Like, again, there's Oracle, SAP kind of information. And they don't want just spatial data, like a satellite image that can be shown on a blackboard and shows a general problem at the national level. That what they're asking for, and what industrial ecology, I hope, is moving toward delivering, is more tested with uncertainty bars, precise product level information. And I think that the satellite-based map connecting real-time remote sensing observations can potentially help deliver more precise environmental data to more precise economic activities. It would also really be a great return on investment for a huge, billions of euros literally invested in an Earth observation facility, which I would perhaps say is underutilized. It's not used day to day to inform decisions in businesses and government. So there's a lot of potential for our field to contribute there. Maybe I'll leave up this slide and then go to questions. So here I just put on the left a few of my papers with Koichiro Kanemoto, where we developed this idea initially, and then also just a few of the papers that I've kept my eye on developing the idea from other authors. But this is not comprehensive, so apologies if I missed one. It's just a quick list, but kind of a starting point for you to click on and read more about the idea. I was not watching my clock, but maybe we can, I'll just jump back into the in-person section here. and go back to Hauke.
Yeah, thanks a lot. Thanks for this excellent talk, input, very inspiring. Yes, let's give you a big hand. Now there's floor for questions. I see that already one hand is raised by Nuno Saab. So please unmute yourself and ask your question to Daniel.
I will also turn my video on so it's a fair exchange. Okay, so I have first one comment. So you say the scientific silo, but in truth, about 60% of the data and remote sensing is used by government for defense. So actually a lot of the data in real time is being taken by, or from the high resolution satellites, is being taken by the government to detect some enemies. Although I had some contact with a company where they were trying, so they are trying to develop blockchain technology to follow food coming from the field to the client, right? And they wanted remote sensing exactly to monitor how much yield is coming from field X to go to place Y. So it's going to happen, and I think some new companies are going to start using this type of system. Okay, the other part is I hear a lot about LCA, and I don't see how that makes much sense in the type of problem that you have in front of you, right? You have this big world change happening at the same time. You have remote sensing monitoring everything, and you have country data. And then what do you have? You have all these super advanced AI models. Why are we then losing time trying to make LCA to understand where the food goes from here to there and make some table to is this or that? Why not just learn directly from the data those type of relationships? So that's my question regarding that part. And there's also a lot of models now using disparate data integration. So basically integrating data that is an image with data that is not an image, for example, country tables like you guys have. So why going through these older schemes and not just let's just go full AI and full machine learning?
Thanks a lot. Just one question beforehand. Would you like to collect some more questions, or would you directly answer the question or reply to the question?
Maybe let's just go one by one and just let's keep an eye on the time as well.
Yes.
Yeah, there's a kind of blockchain, and I don't know if also from my experience working with ESG data, there were always companies who did a great job, and then a bunch of companies who did no job at all and tried to hide and did not want to be in the spotlight at all. So I think that we will again see blockchain for the best companies and a bunch of companies who want to be in the shadows. So I think that there will always be a role for government statistics and kind of modeled and estimated data to understand what people don't want to report voluntarily. Because so I think blockchain will hit that kind of the rich 10-20% of the companies, and there will be a lot who don't, for whatever reason, participate in that.
Can I just have a sub question? But is it okay? Let's say companies are collecting this data to do their blockchain monitoring. Is it fair that that actually happens? Isn't that something that should be maybe actually collected by a central authority and monitor who get actually access to that data? Because if we have companies collecting all this information on yields and all that, those companies also have the upper hand when negotiating with the government, for example.
Yeah, I think that will become an increasing, and that actually needs to become more of a public debate about all of this sustainability is in the public interest, but the more a private company wants to keep its cards close to its chest and not disclose anything. So there will necessarily be some discussion over how much transparency over supply chain and operations the public wants to insist on. You don't look convinced. No, now you're on mute.
I am convinced. I think there's also a discussion necessary there, and sometimes we are not paying attention, and suddenly we find ourselves in the data is just not ours anymore, but the service is there.
All right, Nuno is done. Then I would have a question on my own. I think one of the big potentials of this approach is probably that you could cure weaknesses of current MRIO systems. So what you see is you have some countries with super high quality, but you try to integrate a lot of countries with low standards. And learning from satellite data could also be an approach to come up with the things we don't see, so the informal economy, and trying to retrofit that. Any ideas into that direction?
Oh, it's a genius idea. I never thought of it. 10 points. It's a great idea. There was that cool paper in Nature last summer on the dark economy. So it was mapping. It was with Facebook, I think, and they mapped which buildings exist with no electricity. The kind of buildings who don't show up in those nighttime lights maps of the world. I think it was in Kenya or Nigeria. So there they, yeah, exactly, use satellite like combination. It was that then it was satellite data minus the economic data on the households, and then they locate poverty. So that was a super interesting idea, and I totally like your idea of improving estimates of existing IO tables. It's a great idea.
Further questions, please raise your hands.
I brought also as a small prop this empty frame. This is a CubeSat, a 1U, so NTNU is just building a 6U one, like about this big, and this is 50,000 euros to launch into space when you put some stuff into it. But anyway, it's not that complicated, and they have it kind of comes in a kit. So it will, rotate itself, and you kind of just ask which areas of the Earth you wanted to take a picture of. And anyway, 50K for one of these for a company, Archer-Daniel Midland or something, it's not so much money. So that's actually quite feasible to use these kind of CubeSats, which I won't advocate for. I know they have all these downsides, but
well, I still don't see another hand raised, but then I would have another question from my side. So, Arnold, you go first.
Oops, unmute.
Yeah, I think you pointed already at it then. And I also saw you noted the paper of Jean-Michel. But I think a huge issue is that, having emissions spatially explicit, having loss of wildlife spatially explicit, that is all fine. But then, having your production and your trade particularly spatially explicit, I think that is the real big question. And you even have things like that really, particularly when you do things with Africa, you have a lot of subsistence farming. How do you make a distinction between that stays in the country, that is exported, what quality, all these kind of things. And we basically probably saw that as well, that you did quite recently a study with the group of Bingzhou, who had indeed province-specific export data that was quite unique. And you really see it makes a big difference in the footprints that you get. So I don't know, can you elaborate a little bit on that, how you see that? Or is it like, in a way, what you kind of suggested, that we will be stuck with this for some time to come because there's no real good way of doing things?
Yeah, I mean, I think blockchain is like a kind of promising way for detailed tracking. Or RFID, Walmart was all over RFID a few years ago. So maybe that helps. I don't know, Arnold. It's a great point. I guess we just need to empirically see how it plays out to see which products are more or less. Some of the bulk commodities, I don't know, rice or some of the like even beef, maybe there's just not that much difference. But and some stuff like premium coffee probably is a huge difference between conventional and like this hand-picked coffee in terms of environmental profile. So, but I don't have a good sense overall of how big that problem is, and I mean, especially on global commodity trade, we do well. Yeah, I guess it goes both ways. Like some of the cheap commodities are kind of always the same. That's why they're called commodities. If you can't tell the difference between that rice and that rice, but some of the expensive stuff, the shade-grown coffees, you are not. Yeah, I wonder if you call them commodities because they're actually not interchangeable.
No. Franco, yes, please.
I think presentation very interesting. One thing I just want to make a comment first is one thing that I find very exciting about this approach is it kind of solves it seems that it kind of solves on one part the issue of the time lag that we have with multi-regional input-output tables, and also the inconsistency between trades, right? Between countries. We also have it in countries where statistical offices are very well developed. But anyways, aside from that, I was wondering what is your opinion in tracking more complex products? For instance, tracking rice, tracking coffee might be simpler than tracking other products that are much more complex, that go through multiple phases of manufacturing. And I was wondering whether you can give some insights into that.
Sorry, can you expand on your question one more time? I'm not sure what I should answer, actually.
The question
like some products are more complicated than others, but
is there an increase? Is it more complex to track, for instance, products that go through multiple phases of manufacturing, that are more complex in the sense of they have multiple components and go through multiple stages in comparison with other products that maybe just go through refining and packaging?
Yeah, that's a definitely interesting question. I'm just trying to imagine in my mind, like I always just try to think of the easiest, the medium, and the most complicated projects. So easiest would be rice, very little processing from beginning to end. Medium would be furniture, so wood, often harvested one place, can be made to furniture another place, and then bought a third place. That's not too complicated. iPhone, extremely complicated, has a zillion supply chains. And also in the IO table, of course, you just got these same sector transactions, which it means that the product may change from several companies, all in the electronics assembly sector, but this would be reported as own sector trade in an IO framework, and you would never see those products leave that sector. They could bounce around between several companies in the electronics assembly sector, and then also spatially, we'd never be able to see that they went to a different area, because that would be always inside that economic and spatial constraint. So that's it's a good point. As to how big a limitation that is, I think this also totally depends on which stressors we're considering, and also probably if you apply, I think a very interesting area is spatially explicit stresses. So this heat stress or sea level rise, those cover very big areas, so they will probably mostly hit spatially extensive industries. So you might reduce maybe this, maybe because you're applying broad brushed impact stresses, and you have a lot of spatially extensive industries who are more exposed to those. Maybe that kind of offset each other, and because the iPhone spatially doesn't visit that many different places, maybe it's less at risk. But that's an empirical question. We just have to see what the data and the product specific studies come out with.
Then we have Nuno again.
I think Irlan had his hand in the air first. No, Irlan.
Irlan, do you have a question? Then, if not, Nuno, go ahead. I think it was just a race, and then.
Yeah, he maybe gave up. So actually, this is my second question was basically the same thing that Franco was asking now. Mm-hmm. So you have all this complexity, and you are looking at this complexity of the supply chain. Mm-hmm. Why don't we just look if there's an increase of consumption in place X, Y? Let's say in Europe now we are buying 10 million more iPhones. Mm-hmm. How does the remote sensing actually detect changes happening somewhere else, right? And there are models, many models to look at causal relationships between data at the same time, right? Mm-hmm. But my question is, okay, we are looking at the supply chain and concerned about the supply chain, where it's coming from, blah, blah, and I understand that part is necessary for management. But in terms of monitoring and finding the implications of a specific new industry or an industry or some kind of industry that is making impacts on the environment, mm-hmm. Is it that really necessary? Because the data should be able to tell you that. And in some cases, it won't tell you, because maybe, zinc mines are going to be, I don't know, they are underground and the remote sensing is not going to detect that. But wood cutting, for example, remote sensing is going to detect that. Mm-hmm. So my question is it necessary all the time to go through such a complex understanding of a supply chain, and instead just going through data-driven approaches?
Yeah, that's a great point, that the measurement and monitoring might be a bit different. So maybe some kind of first cut IO or first cut spatial assessment would help you find expose the initial set of spatial linkages that iPhones cause mining in Congo. But then when you want to monitor that on a year-on-year basis, and when Apple actually decides to switch their mind from here to there, that monitoring might take place at a much more detailed, those little changes and little fine-tuning and adjustment might be too high resolution to be caught by IO type approaches. Maybe then like kind of this Bitcoin RFID, the product specific approach, or but I guess in this case, basically the company should engage in that particular supply chain that they're really focused on. Yeah, when I did some work on the spatial footprint of cities as well, and we all, city level footprinting, and we kind of quickly realized early on that this was a fairly decent way to get a snapshot of where a city has its footprint, or kind of what the total footprint of a city is. But the measuring of the changes, and if they have a climate action plan, and how those kind of itemized interventions, will they have an effect? That's very hard, and maybe a macroeconomic tool like IO is not the right approach. Maybe then it's better to indeed go to this more specific granular models that you refer to.
Further questions?
Yeah, I would also, coming back to that though, there are, as researchers, we often focus on where we can find data, like what's the metaphor, the drunk looking under the street light to find his keys, because that's where the light is, that's not necessarily where the keys are. So we are naturally drawn to data-rich areas, but there are also big sections of the economy, and it's kind of, I have a side interest in this finance applications, because I think this ESG investing is a very potentially powerful section of change in society. And that's an area where data are very poor, and figuring out if a bond drives this mission or is exposed to that kind of climate risk, that's really tricky. And to go like blockchain level detail from like a bond traded on this market to the blockchain specific study is hard. So I think that there kind of is, I continue to believe in the macroeconomic coverage that IO offers. I think that will continue to be valuable, although I totally understand that when you get to studying an iPhone or a basket of strawberries, it's not the right tool to be using. But I think both have their place and will continue to have their place.
Further questions? I don't see a hand raised, so I have another one. What the input-output data set you're using has as a nice characteristic is that EORA is available from 1970 to today. And when we look at satellite data and the generations of satellite, well, we see that the once revolutionary satellites in the 1970s are now a little shitty, so to say. So if, of course, industrial ecologists are also interested in tracing the development of specific environmental impacts. And when you would start with developing algorithms and applications, would you rather try to facilitate the newest generations of satellites, or would you rather aim for having applications that would allow to go back to 2005 or so?
I don't know. I would be more interested maybe personally, and if I were running an institute, in collaborating with Google or Amazon or the European Commission on making things better tomorrow. So I would be very forward-looking about how can we make changes that help us get to a decarbonized society, that help us quickly reduce like forest cover loss. So I think I'm kind of a pragmatic person and looking forward at what we can change first. I think you can study the history forever and find better and better descriptions of what happened. So I don't know, unfortunately, if I had to allocate scarce resources, the historical perspective, it is important to help you understand how you got here and decompose the major drivers of an issue. But often you kind of know the major drivers, and you're actually more curious about how a new intervention will create a change. And that's, I would say, more forward-looking, and I would actually turn to the newer research first. It's a bit broad answer then.
Yeah, but valid answer. Well, I could, of course, argue that learning from the past will also facilitate a transition, but I agree. Are there any further questions? If not, I think we're 5 minutes ahead of schedule. So I would like to thank you again, thank you very much for joining the EEE lecture and giving this nice and inspiring input. And I would like to motivate everyone to give you another big hand.
Thank you very much.
And yeah, then I wish you a nice evening, and I look forward to speaking to you in person again as soon as this Corona crisis is returning to normality.
Me too. Echo that. Thanks, everyone.
Thank you.
Okay, cheers, Dan. See you again.
Bye-bye.
Bye.
Cheers.
Bye.